guys, welcome back. So today you can consider it your lucky day because we are going to have 7 opportunities to practice our favorite word. Yes, factor. Alright, so let's do this. So we have fun problem number 1, our only fun problem. How many problems are we going to knock out? 7. That's why it's our lucky day. So the directions, surprise, read factor completely, and as always a disclaimer, if not factorable, so state. So let's go ahead and write our first fun problem. So where am I? Problem A, we have 2x squared plus 7x minus 15. Fantastic. So when it comes to factoring, prerequisite step, regardless of the technique, is to watch out for common factors. Unfortunately, 2x squared, 7x, and 15 don't have any factors in common other than 1, so we're good. So now, what are we going to do? So I'm going to ask myself, how many terms do I have? If I have 4 terms, then we factor by grouping. If we have 3 terms or a trinomial, then we do what we got to do. So from the other video we had said, if we have a trinomial, I'm going to cross my fingers and hope that the leading coefficient is 1. But unfortunately, no matter how much I squeeze, the leading coefficient is not 1. So if the leading coefficient is not 1, we can't go straight to throwing down parentheses. But it's okay, I got you. Okay. So if we have a trinomial and the leading coefficient is not 1, how are we going to factor it? We are going to factor it by using the AC method. The gist of the AC method is to take your 3-term expression or trinomial. Then you're going to take the middle term and split it. So you can then have 4 terms and then factor by grouping. So let's do this. This is not the only way to factor, but given that I'm not seeing you face to face, this is, I think, the most cleanest way that we can talk about this topic. When we resume, I'm going to show you a different technique. Okay, so let's do this. So again, when it comes to factoring, prerequisite step is to watch out for common factors. We had already said that there aren't any. Trinomial, is the leading coefficient 1? Is the leading coefficient 1? The answer is no. So because the leading coefficient is not 1, let me speak to myself. Use the AC method to factor. Use the AC method to factor. So if you have been seeing the video since day 1, I really hope you are. If you're my student, then you know that I like to talk to myself on paper. So remember, we are factoring trinomials of the form ax squared plus bx plus c, regardless if the leading coefficient is 1 or not. Okay, so the leading coefficient, that's our a, coefficient of the middle term, that's our b, and then the constant term, that will be our c. So let's do this. So how do we use the AC method to factor? So the first thing we do, we want to find factors of A, C that add up to B. Okay, that's too many words. Let me go ahead and identify A, B, and C. So leading coefficient is 2, that's our A. Coefficient of the middle term is 7, that's our B. Constant term is negative 15, so that's our C. Okay, how do we begin to factor? Okay, so it says step 1, find factors of A, C that add up to B. So I want to find factors of A times C that add up to B. So I'm like, okay, 2 times negative 15 is negative 30. So I want to find factors of negative 30 that add up to 7. And I know you're hot, you can do it in your head. Maybe I can too. But to facilitate the process, I'm going to go ahead and write out the X game. Okay, so let's do this. We talked about this in the earlier unit. Okay, so the reason why we call this the AC method is because we focus on the values of A and C. Okay, that's my theory. Okay, so product of A and C will give us negative 30. Value of B will give us 7. So friendly reminder, the side should multiply to the top and the side should add up to the bottom. Okay, so we want factors of AC that add up to B. Okay, factors of AC that add up to B. So I'm like, okay, what are factors? Oh, this was not the first problem I was going to do. Oh, too late. Okay, so I'm like, what are factors of negative 30 that add up to 7? I think there's a 10 and 3 there. And then because the product is negative, one of these bad boys will have to be negative. Because the sum is positive, then the larger factor needs to remain positive. So let's go ahead and put the negative on the 3. The biggest recommendation I can give you is this. if you use the X game to facilitate your factoring, love yourself. Check your X game. If you check it, then you're on track. If you don't check it, and if you made a mistake, you're gonna have a big technical difficulty down the line. So check it. Product is -30, sum is +7, so we're good. So let's proceed. So we are going to go ahead split the middle term. How? By using the side numbers in the X game as the coefficients of the middle term when split. That's too many words, but sometimes I got to use my math words. Okay, so English. Let's go ahead, look at the middle term. Let's look at the variable part. Variable part is X. So we're going to go ahead attach that same variable part to the sides in the X game. Okay, so we're going to replace the 7x with +10x and -3x. So let's do this. So again, the gist of the AC method is to split the middle term so we can have 4 terms and factor by grouping. So let's do this. So we're going to copy the first term as is. We are splitting the middle term, and it's okay if you switch the sides. If you put -3x and then 10x, I'm cool. What's the worst thing that can happen? Nothing, okay? But if your sides are flipped, then the binomials will be flipped. It's no big deal, okay? So one side number is 10, +10, so let's go ahead put +10x. And the other side number is -3, so let's go ahead put -3x. So again, we're splitting the middle term, okay? And then you bring down that last term as is. No matter what you're doing, you are more than welcome to rewrite things as needed. Rewrite means you write it again, okay? It looks a little bit different. We're not changing anything. If we were to simplify this, the sum gives us 7x, so we still have the undercover original trinomial. Okay, AC method, how does that work? Okay, find factors of AC that add up to B, and then go ahead split the middle term. Okay, I'll put arrows, like funny arrows. Okay, find factors of AC that add up to B, split the middle term, and then factor by grouping. So from the earlier video, how do we factor by grouping? If you have 4 terms, you make teams of 2. Group the first 2 terms, group the last 2 terms. Let's go ahead and see what we're left with when we look at the first group. When we look at the first group, 2x squared and 10x have a common factor of 2x. So let's go ahead and factor it from the group. When we do, 2x squared over GCF will leave us with x. -10x over 2x will leave us with 5. So one group down, one more group to go. For the second group, I know that you know that -3x, I'll just ignore the negative. I know that you know that 3x and 15 have a common factor of 3, but I said it since day 1. When you take out a common factor, it's to your advantage that when you do so, the first term that you're left with is positive. Who cares if the rest are negative? But we need to start on a positive note so things look pretty. That's just the short version that I gave you. Okay, so instead of factoring out a +3, we're going to go ahead factor out a -3. Okay, what happens if you factored out a +3? Nothing, like literally, things are not going to match up and you're not going to be able to proceed as cleanly. So let's do this. -3x divided by -3 will give us x. -15 divided by -3 will give us 5. Okay, fantastic. So how do we factor by grouping? So we make our groups of 2, and then we're going to factor out at this point, surprise, the common binomial factor. So let's go ahead factor the x plus 5 from the expression. So when we factor out the GCF for that common binomial, let's do this. First product over x plus 5, the x plus 5's cancel, and that will leave you with 2x. Second product over x plus 5, the x plus 5's cancel, and that will leave you with -3. Okay, cool, and that's the end of that. Okay, well, I think I boxed this prematurely. So we factored. Again, what does it mean to factor? Factor is code for write me as a multiplication problem. But the question is, did I factor all the way? Okay, let's see. X and 5, can we take out a common factor? No. 2x and 3, they don't have any factors in common. So we have factored and all the way or completely, so we're good. How do we check it? Same way we did before. We FOIL it out and then confirm we get the original trinomial. So let's go ahead and do a problem that we did back in the day, yesterday. Okay, or it may have been today, depending on when you watch the video. Okay, so problem B. We have x squared plus 10x plus 16. Okay, x squared plus 10x plus 16. And it's like, oh, this is cool, Miss Torres. Oh, my name. I have to stop saying my name, okay, in case I say something bad. Okay, so let's do this. So we have x squared plus 10x plus 16. It's like, this is fantastic. This is something that we did the other day. Okay, so prerequisite step is to watch out for common factors. We don't have any. How many terms do we have? 3. Okay, show off your vocab. Oh, we got a trinomial. Trinomial. Is the leading coefficient 1? Let me cross my fingers, and it is. If the leading coefficient is 1, we don't have to use the AC method to factor. Can you? Sure. But if I don't have to, then I'm not. So let's do this, okay? So what did we do? Since the leading coefficient is 1, we're going to go straight to answer, okay? So we're going to go ahead, throw down parentheses, and focus on getting the first terms. The product of the first term needs to give us that x squared. The product of the first term needs to give us the same thing, sorry. And in this case, we're going to do that by using x times x. To complete the binomial factors, we want to find factors of c that add up to b. So then I'm like, okay, what are factors of 16 that add up to 10? If my eyes don't fail me, I think it's 8 and 2. But I have a really bad habit of second guessing myself, so I'm going to go ahead and do an X game for fake extra credit. So I'm like, factors of C that add up to B. I'm like, okay, what are factors of 16 that add up to 10? I think we have said 8 and 2. Let's check it. Product is 16, sum is 10, and then we're going to use the sides to complete those binomial factors. So that's our answer. Cool. Now, can we do this problem again by using the AC method? Sure. Okay. The only reason why we're doing this problem again is because one of the questions is what is it that I have to use the AC method? Well, check it out. You can use the AC method to factor any trinomial. Okay, use the AC method to factor. In other words, you can use the AC method to factor any trinomial. Okay, so you can use the AC method to factor any trinomial. Again, the gist of the AC method is split the middle term so you can have 4 terms, so you can then factor by grouping. Okay, but the question is, do we always have to use the AC method to factor? No. Okay, if the leading coefficient is 1, go straight to answer. But if you're like, no, me and the AC method are BFFs, then always use the AC method. Okay, but the only time you have to is if you have a trinomial and the leading coefficient is not 1. Okay, if the leading coefficient is not 1, then use the AC method. If the leading coefficient is 1, you got some options. Go straight to answer or use the AC method. It's a personal choice. Okay, so I'm going to go ahead and do this problem again. We already know what the answer is, so please just act like you're surprised. Okay, so I'm like, oh man, I don't know how to factor this. Let's go ahead and use the AC method. Okay. So the AC method, we want factors of AC that add up to B. And I'm going to confess something to you. When we did problem B the first time around, even though we didn't do AC method, the X game is always A times C. When the leading coefficient is 1, well, let me go ahead and highlight the coefficients. The values for A, B, and C. So leading coefficient is 1. So that's our A. 10 is B, and constant term is 16. That's our C. Okay, AC method. In this case, it's going to be 1 times 16. Okay, when the leading coefficient is 1, we don't really use the AC method. So instead of saying 1 times C, 1 times C, 1 times C, then we just say C. To highlight that if I use both A and C, I got to do the full-blown AC method. If we just focus on C, because the leading coefficient is 1, then we go straight to answer. Okay, I said too much, so let's do this. So if we do problem B again by using the AC method, let's do the corresponding X game. We want factors of AC that add up to B. Product of 1 and 16 is 16, and value of B is 10. So then I'm like, okay, what are factors of 16 that add up to 10? We said it before, 8 and 2. And then we're going to go ahead and use the sides to split the middle term. the variable part of the middle term reads x, so we're going to replace 10x with 8x and 2x. So let's do this. So we're splitting the middle term, the first and last they put. So we have 8x plus 2x plus 16. And remember, we're not changing the trinomial. We are just rewriting it. So writing it again. Okay, 8x plus 10x, bam, 10x. Now that we have 4 terms, let's go ahead factor by grouping. So we'll group the first 2, the last 2, and take it away. From the first group, x squared and 8x have a common factor of x, so let's do this. So that will leave us with x squared over x is x, and 8x over x will leave us with 8. So one group down, one more to go. Group number 2. 2x and 16 have a common factor of 2. So let's see what we get when we factored from the group. Let's go ahead and put our plus sign while we're at it. First term over common factor is x. Second term over common factor will leave us with 8. So fantastic. So at this point, the binomial factors should match. Someone asked me, what if they don't? Then check your x game, because that means that the x game is wrong. So let's do this. Let's show the reader what we're left with when we factor out our GCF, or the common binomial. When we factor out the x plus 8, first product over common factor, the x plus 8's cancel, and that will leave us just with x. Someone said, do we have to put a triangle? Of course not. I just need to see your work. Second product over common factor, the x plus 8's cancel, and that will leave us with 2. Okay, if you're having a moment with what I did, go ahead and look at the first video on factoring. If I did the playlist, it'll be like the first video in the playlist. Okay, let's do this. So that's 2 problems down, and we said it was our lucky day, so we need 5 more to get to 7. Where am I? Problem C. So problem C, we have oh, something spicy. I didn't even wait for E. Okay, we have 4m squared plus 5mp minus 6p squared. Oh, this is pretty spicy. I know. It's because you know what? I trust you. I know you can handle it right now. Okay, so prerequisite step, watch out for common factors. Unfortunately, none of these terms have a common factor other than 1, so there's no GCF to yank out. I'm sad. Alright, let's do this. Trinomial, is the leading coefficient 1? It is not. Okay, so what are we going to do? We're going to use the x game to split the middle term. I don't have space over here, so I'm going to do the x game right below. Okay, so the corresponding x game, remember we're using the AC method, so we want factors of AC that add up to B. Let me identify values of A, B, and C for my peace of mind. Leading coefficient is 4, so that's our A. Coefficient of the middle term is 5, so that's our B. Normally I would say constant term, but because we have a second variable, then C is no longer the constant term. C is the coefficient of that third term. This is where me and some books fight. They will say that C is the entire 6p squared. I'm not going to address that, but there's a reason why I just say A, B, and C are the coefficients, okay? So value of C is -6. I think the book will say -6p squared. Do what you got to do as long as you get it right. Okay, corresponding x game, we want factors of, I didn't even do it right, that's why I get for fighting with the book. Alright, corresponding x game, we want factors of AC that add up to B. Product of A and C, namely 4 and -6. 4 times -6 will give us -24. That's what I get for going on a tangent. I will try not to do that again. I cannot guarantee it though. That's the ugliest -24, okay? But please make sure you write it nicely. This is why we use pencil, okay? Factors of AC that add up to B. Product of 4 -6 is -24. Value of B is 5. So then I'm like, okay, what are factors of -24 that add up to 5? I'm going to put the numbers first and then the signs later, because that's how I think. So I know that you know that 8 times 3 is 24. One of these bad boys has to be negative. Because the sum is positive, then the larger factor will have to be positive. So let's check it. Product is -24, sum is 5, so we're good. So let's go ahead split that middle term. Okay, so we have 4m squared, and we are going to replace the middle term with, let's look at the variable part. Okay, variable part of that middle term is MP, so we will replace it with 8mp and -3mp. You got this, okay? So 8 is positive, so plus 8 MP. 3 is negative, so minus 3 MP. And remember, we are not rewriting, we are not changing anything. We are just rewriting our expression, okay? So let's do this. So AC method, do your X game or think it in your head. Split the middle term, and now that you have 4 terms, we're going to factor by grouping. So let's group the first two, we group the last two, we check the X game, so there should not be any surprises. For the first team, the terms have a common factor of a 4 and a m, so let's go ahead and factor it from the group. When we do, first term over common factor will leave us with m. Second term over common factor will leave us with 2p. Okay, one group down, one more to go. And remember, pause and rewind as many times need be. Second group, the terms have a 3 in common. The terms have a p in common, but you know the drill. When you take out a GCF, you need the first term that you're left with to be positive. So we're going to factor out a negative 3p. First term over common factor will leave us with m. Second term over common factor will leave us with positive something, positive 2p. Okay, so at this point, it should not be a shock that the binomial factors match. If they don't, that means you didn't check your X game, so please be careful. Let's go ahead and finish it off for the win. Let's factor out the common binomial. So when we do, we have m plus 2p, and let's show the world what we're left with when we factored from the expression. First product divided by GCF, the binomials cancel out, and that will leave you with 4m. Second product over GCF, the binomials cancel out, and that will leave you with negative 3p. I think we watched for common factors from the beginning, but just in case, let's check it now. I know we factor because we have multiplication problem. Again, factor is just code for write me as a multiplication problem. But the question is, did we factor completely? Okay, m and 2p, no factors in common other than 1. 4m and 3p, no common factors other than 1. So we're good. So we have factored another way or completely. Okay, so we have 3 problems. We have 4 more to go because remember, it's our lucky day. And again, pause and rewind as many times you need be. If you need to take a break, YouTube will know where to pick it up. Okay, where am I? Problem D. But I have to look for it. Oh, ¿dónde estamos? I think that. Hold on. Okay, there I am. Okay, problem D. Okay, I know I probably should have put pause on my recorder, but my cheapy machine is my TB machine sometimes gives me problems when I put pause, and then it stops recording, and I didn't realize it. Okay, problem D. So we have 2x squared minus x plus 3. 2x squared minus x plus 3. So that's an x. Okay. So prerequisite step, watch out for common factors. Unfortunately, these terms don't have any factors in common other than 1. Okay, so we're good. Trinomial, is the leading coefficient 1? Of course not, because we want to practice when the leading coefficient is not 1. So since the leading coefficient is not 1, let's go ahead and use the AC method to factor. Okay, so I don't have a lot of space, so I'll do the X game here. So the X game, we want factors of A, C that add up to B. So let me identify the values for A, B, and C. Leading coefficient is 2. That's our A. Coefficient of the middle term is 1. That's our B. Constant term is 3. So that's our C. Product of AC, namely 2 and 3, is 6. Value of B is negative 1. So let's do this. So we want factors of 6 that add up to negative 1. And I'm like, okay, what works? 2 and 3. No, that's 5. 1 and 6. No, that's 7. I think there's not a solution to the X game. But if you know me, you know that I'm not quick to say no solution. When it comes to factoring, if I can't find a solution to the X game, it may be the case because the X game doesn't have a solution, or 2, I haven't slept, so I just can't see it. So let's do a factor table, listing them in order. So 1 times 6 is 6. 1 times 6 is 6, but the product is positive and the sum is negative, so both factors would have to be negative. Unfortunately, the sum is not -1. Okay, 2 is a factor. 2 times 3, they will both have to be negative, and that sum is not -1. Okay, 3 is a factor, but it's already in our list, so we are going to stop. Okay, if you list the factor pairs in order from smallest to largest, or largest to smallest, whatever flows with you, if you list the factor pairs in order, once you get a factor that's in your list, you know you're done. Okay, so the moral of the story is this. Okay, X game has no solution. Okay, so since, let's speak to ourselves. Okay, since the X game has no solution, since the X game has no solution, then the trinomial is not factorable. That's not how you say it, but if I don't say it like that, I'm not gonna be able to spell it. Okay, so as we did in the earlier video, how can I tell if our trinomial is factorable? Okay, if you do an X game and it turns out that the X game has no solution, then that means that the trinomial is not factorable. Okay, the books typically don't write not factorable. The books typically write prime. Okay, prime polynomial. Pretend you can read that. Okay, the books typically write prime, but it's really up to you. For me, the words not factorable resonate with me more. If I am asked to factor and I'm like, this one I can't, I cannot write it as a multiplication problem, then this is why I write not factorable. But it's a personal choice. Not factorable or prime, we're good. You don't have to put your explanation on the test, just say not factorable. Okay guys, so how many problems is that? I think that's 4. We don't have lucky time until we do all 7, so let's go ahead and knock out problem E. Okay, and I have it available right now. Okay, too many papers. Okay, letter E, let me zoom out. Okay, so letter E, we have negative, oh, this is spicy, you're gonna like it. Okay, negative 6w to the 5th times w to the 5th plus 63 w cubed plus 33w. So we have a trinomial. Prerequisite, watch out for common factors. I believe for the coefficients, the biggest number, the biggest factor that the terms have in common is 3. If we're not sure, we can do a ladder, but I think it's 3. And if it's not, we'll find out right now. So the coefficients have a common factor of 3. They also have some variables, 5, 3, 1. So they have 1 w in common. And then you know the drill. Let's go ahead, factor out a negative 3w. Okay, so let's show the world what we're left with when we factor out the GCF from the trinomial. First term over common factor, that will leave us with 2w to the 4th. Second term over common factor, that will leave us with negative 21w squared. Third term over common factor, that will leave us with negative 11. Okay, fantastic. So we still have a trinomial. It's still kind of ugly, but at least it's toned down by a factor of 3w. So now, trinomial, is the leading coefficient 1? It is not. Okay, so let's go ahead and use the X game. Okay, I'll do the X game right here. I think it was a happy accident. I always do the X games on the side, but when we ran out of space, I think I like the layout of putting it below. Okay, so we want factors of AC that add up to B. So let me go ahead, zoom in. Okay, there's no need to squint. Factors of AC that add up to B. Let me identify values for A, B, and C for my peace of mind. Product of A and C, namely 2 and negative 11, will give us negative 22. Value of B is negative 21. So then I'm like, okay, let's find factors of negative 22 that add up to negative 21. And I think there's nothing, because when I see 22, I'm like, okay, 2 and 11. that doesn't work. I can't think of anything else, so I'm gonna do a table. So I don't want to say no solution right away. So we'll start with 1. 1 and 22, where the larger factor will have to be negative. So we check it. Product is negative 22. Sum is negative 21. So I lied. Okay, so this is why I always do the factor table before I'm quick to say no solution. Because it may be that we generally don't have a solution, or it may be that I overlooked it. Okay, so let's do this. So the sides are going to be 1 and negative 22. When we split the middle term, we're going to attach that variable part. So let's go ahead, attach the w squared to the sides. So let's do this. So let's split the middle term. So the first term stays as is. And we're going to replace the middle term with 1w squared and negative 22w squared. So plus 1w squared and then minus 22w squared. And let's go ahead, bring down that third term. Okay, I'm going to go ahead, circle our GCF. I'm going to put a drop down arrow in an effort to remind me not to forget to bring down the GCF. Right now I'm in my zone and I just want to factor that trinomial. Okay, so now that we have 4 terms, let's go ahead, factor by grouping. We'll group the first 2 and we'll group the last 2. Okay, from the first team, what can we factor out? 2w to the 4th and 1w squared have a common factor of w squared. Okay, when we factored from the group, that will leave us with first term over common factor. That will leave us with 2w squared. Second term over common factor, I'm like, what's w squared divided by itself? I'm like, oh, 1. So 1 group down, 1 more to go. Second group, the GCF, I think it's 11. But love yourself and go ahead, factor out negative 11. Okay, so let's see what we're left with when we factor out the negative 11 from the second group. First term over common factor, that quotient will leave us with 2w squared. Second term over common factor, the quotient will leave us with 1. Okay, I'm not gonna lie, I was like feeling nervous, hence the lack of excitement in my voice. But now I'm pumped. Look, I'm smiling. Okay, I'm pumped because the binomial factors match as expected. So let's go ahead, factor it out from the expression. So let's go ahead, earn our full credit and show the reader what we're left with. So again, let's not forget to bring down the GCF. You know what? I think I'm gonna bring it down at each step. Okay, so I'm gonna bring it down at each step. Like the brackets get in my way, but you know what? This is gonna be the only way that I'm not gonna forget it. Okay, so let's go ahead, show the reader what we're left with when we factor out the binomial from the expression. First term over common factor, the binomials cancel out and that will leave us with w squared. Second product over common factor, the binomials cancel out and that will leave us with minus 11. And let's not forget to bring down the GCF that we supposedly brought down at each step. So the directions were factor, okay, or factor completely. So we have factored. Again, factor is code for write me as a multiplication problem. The question is, did we factor all the way? I think so. First binomial, terms don't have any common factors other than 1. Second binomial, same speech. Terms don't have any factors in common other than 1. Okay, so how many was that? I forget, but I know we're doing a total of 7. Okay, and I have 2 more problems on my paper, so I guess we haven't quite reached 7. Okay, letter F. Okay, we have 6a squared m squared plus 22am minus 84. I know you're tired, but this is the deal. If I only do 2 problems, what's going to be the number 1 complaint? Oh, teacher doesn't do enough problems. If I do many problems, oh, teacher does many problems. So there's no winner here. Okay, it's not always pink. Alright, let's do this. We got a trinomial, a funny trinomial, but let's knock it out. Trinomial, is the leading coefficient 1? It is not. Okay, cool. Can I factor out a GCF? Yeah. The terms, I think it's just 2. 2, no a, no m. Yeah, it's just 2. So let's go ahead and show the world when we factor out of 2. Okay, when we factor out of 2, first term over common factor, that will leave us with 3a squared m squared. Yeah, that looks really weird, but it is what it is. Second term over common factor, that will leave us with 11am. Third term over common factor, that will leave us with negative 42. So again, we have factored. Again, what does it mean to factor? Factor is code for write me as a multiplication problem. But the question is, can I break it down more? We are going to assume that we can until we realize that we cannot. Trinomial, is the leading coefficient 1? No, it's not 1. So we're going to use AC method to factor. Okay, let's go ahead and do the X game. We want factors of AC that add up to B. So we want factors of A times C, whatever 3 times negative 42 is. Who has a calculator? Okay, it's negative 126. Value of B, it's 11. Okay, so we want factors of negative 126 that add up to 11. Do you think I know the answer? Of course not. Okay, so we're going to go ahead and do a factor table. Do we have to? No. I mean, I already know the answer because I have the answer key. But I'm not going to have the answer key on the test, so I want to show you my thought process. Okay, so what we're going to do right now, you will probably do as well. But what I want to point out is that you don't have to write it on paper. If you love yourself, I recommend that you do. Okay, so let's go ahead and do the factor table. So we have, this is in my way. Okay, I think I can see it. Okay, so we have 1 times 126 is positive 126. We want it to be negative. One of these bad boys has to be negative, but because the sum is positive, then the larger factor will have to remain positive. So in English, 1 is negative. That sum is nowhere near 11, so let's do this. So I'm like, is 2 a factor? It is, because we're cool like that. It's 2 and 63. Is 3 a factor? Probably, but I have no time to do it in my head. And why would I? Okay, is 4 a factor? Who knows? Okay, look, it's not. How can I tell that it's not? Because it's not an integer. Okay, is 4? Is it 4? Is 5 a factor? It's not, because we're cool like that. But sometimes I don't even like think. I just punch in numbers. Okay, is 6 a factor? Yes, 6 and 21. Let me see what that sum is. Negative 6 plus 21 is negative. I don't know how to use my calculator. Negative 6 plus 21 is 15. Pretty close. So maybe the next one is the winner. So we're at 6. So I guess up next is 7. Is 7 a factor? Okay. So it is. Let's go ahead and see what that sum is. Negative 7 plus 18. You think I could do that in my head, but I can't because I'm tired. Alright. But that sum is 11. Okay. So do you have to write out the factor table? You don't. But you know what? I recommend that you do. Okay, if you don't write it out and you look at your notes, I don't want you to be like, where did negative 7 and 18 come from? I already passed this class. My goal is for you to pass this class too. Okay, so let's do this. So again, the gist of the AC method is to split the middle term so you can have 4 terms and then factor by grouping. Let's go ahead, split the middle term. The variable part of the middle term reads AM, so our sides, the variable part, it's gonna also have to read AM, like in the morning. I'm not sure what time you're watching this video. Okay, so let's go ahead, split that middle term. Okay, so the first term reads 3a squared m squared. We are splitting that middle term and replacing it with negative 7a, with negative 7 a.m. and positive 18 a.m. Negative 7 a.m., positive 18 a.m. And then we bring down the rest of the problem, which is minus 42. Okay, so let's do this. And then we don't want to forget to bring down the common factor. So we're going to do that right now. I'm going to put a big grouping symbol. You can put parentheses or brackets, whatever you like. Okay, let's zoom in. Now that we have 4 terms, let's factor by grouping. We're going to go ahead, group the first 2, and then we're going to group the last 2. So let's take it from there. Looking at the first group, 3a squared m squared and 7am have a common factor of nothing for the numbers. For the a's, 1 factor of a. And for the m's, 1 factor of m. So it's just am. Let's do this. First term over common factor, that will leave us with 3am. Second term over common factor will leave us with -7. A's canceled, m's canceled. So that's it. Okay. So one group down, one more to go. Second group, what is the greatest common factor? To tell you the truth, I have no idea, and I don't have my notes with me, so I can't cheat. So I'm gonna do the latter. So 18 and 42, they're both even, so I'm gonna just divide by 2, but you can do whatever you want. So when we divide by 2, 2 goes into 18 9 times, and into 42 2 1 times, or 21, how people speak. We could keep dividing, in this case by 3. 3 goes into 9 3 times, and into 21 7 times. The leftovers don't have any more factors in common other than 1. So the GCF, friendly reminder, GCF is given by the product of all the numbers to the left of the ladder, namely 6. Okay, so you don't have to think about oh man, just do the ladder quickly. Okay, and if you have a calculator, then this is a faster procedure. So the terms have a common factor of 6. There's no variables. So let's go ahead, factor out of 6. I'm running out of space. First term over common factor, 18am over 6 will leave us with 3am. Second term over common factor, -42 over 6 will leave us with -7. Cool. Alright, so let's do this. Let me go ahead and bring down the GCF that we had to begin with. Alright, at this point the binomial factors should match. So let's go ahead, factor it from the expression. Okay, so we have GCF, namely 3am minus 7. And let's see what we get when we factor it from the expression. First term over common factor, the binomials cancel out, and that will leave you with am. Second product over common factor, the binomials cancel out, and that will leave us with 6. And let's not forget the GCF that we yanked out from the start. So ladies and gentlemen, did we factor? Yeah. Did we do it completely? I hope so, because I'm already tired. First binomial, terms don't have any factors in common other than 1. Second binomial, same speech. So the moral of the story, did we factor completely? Yes, we did. Okay, so we are not lucky yet because we have yet to reach our 7th problem, but the 7th problem has arrived now. Okay, if you need to take a break, go for it. YouTube will know where to come back. Problem G. Oh, it's really spicy. Okay, so we have 12w to the 6 minus 38w cubed z squared minus 72z to the 4th. Okay, so what is the GCF for the coefficients? You know what? I have no idea. So what am I gonna do? I'm gonna do a ladder. I don't know how much space I'll need over here, so I'll do it above. So we have 12, 38, 72. They're all even. So let's go ahead, divide by 2. When we divide by 2, 2 goes into 12 6 times, into 38 20 19 times. Sorry, that's how I was dividing. 2 goes into 76 3 6 times. I think it's 36 times, but don't quote me on that. Alright, 6, 19, and 36 don't have any factors in common other than 1, so the GCF was just 2 for the coefficients. There's a lot of variables, and I'm really hoping that we can tone this down. We have W, no W, so no W to yank out. What about the Z's? First term doesn't have a Z, so that's it. Okay, so the GCF is just a 2. Let's go ahead, factor it from the trinomial. First term over common factor, that will leave us with 6w to the 6th. Second term over common factor, that will leave us with -19w cubed z squared. Third term over common factor, that will leave us with -36z to the 4th. So we have factored, but did we do it all the way or completely? I really don't know. Okay, I generally don't know. We're gonna do the X game. If the X game has a solution, then the trinomial is factorable, and we proceed. if the x game doesn't have a solution, then the trinomial is not factorable. So we stop right there. But you know the speech, I'm going to assume that it is until I realize that it's not. Okay, so let's do this. Corresponding x game, we want factors of AC that add up to b. Factors of a times c that add up to b. Product of a and c, namely 6 and negative 36, is negative 216. Value of b is negative 19. I know that you know that I don't know that answer off the top of my head. For the purpose of time, I'm going to omit the factor table and then just give you the sides. If you're like, oh, we love the factor table, well, too late. You should have said something in class, okay? But after I do the factor table, I realize that the sides are 8 and negative 27. So let's check it. Product of 8 and negative 27 is negative 216. Sum of 8 and negative 27 leaves us with negative 19. Check. Okay, so let's go ahead and split the sides. The variable part of the middle term reads w cubed z squared. So check it out. When we split the middle term, let's go ahead and attach those w's and z's. I don't have enough space. It's okay. I will make space below. Okay, so let's copy the first term, the last term, and then split the middle term using the sides in the x game. So we have 6w to the 6. We're splitting the middle term. We'll replace it with positive 8 w cubed z squared and negative 27 w cubed z squared. Please don't forget to bring down the rest of the problem, namely that third term, which is now number 4, and this trinomial, which is now 4 terms, was being multiplied by that common factor of 2. Okay, so let's do this. Now that we have 4 terms, for the last time in this video, let's factor by grouping. We're going to group the first 2, we're going to group the last 2, and then knock it out of the park. Oh, baseball, how I miss D. First binomial, the GCF, 6 and 8 have a common factor of 2. How many W's? 6, 3, or just 3 W's? How many Z's? That's a lie, okay, because the first term doesn't have any Z's. So if we keep our cool, sorry, wrong words. Thanks to our hard work, the GCF for the first group is just 2w cubed. Let's do this. Let's see what we get when we factor it from the first group. First term over common factor, that will give you 3w cubed. Second term over common factor, that will leave you with 4. The w's cancel and we're left with z squared. Cool. One group down, one group to go. Second group, what's the GCF? 27 and 36. Oh, who knows her times table? I think it's 9. Okay, I think so. Let's go with that. Okay, so we're going to factor out a 9. How about some variables? W, no W. How about some Z's? Yeah, 2 Z's, 4 Z's. So we're going to factor out 2 Z's. And then we're going to factor out a negative 9z squared. Okay, so let's see what we left when we factor out the GCF from the second group. First term over common factor, that will leave us with 3w cubed and the z squares cancel. Second term over common factor, that will leave us with 4 and the quotient of the z's will leave us with z squared. Okay, the worst thing that you can do to yourself is this. Oh, look, the first binomial is 3w cubed plus 4z squared. I'm just going to copy that and not do the math. That is such a disservice, because then you're really not going to know if you nailed it or not. Do the actual math. Actually factor it out. And then if the binomials match, you're like, nailed it. Okay, like that show. They should pay me some money for that promo. Alright, let's do this. Let's bring down the rest of the problem. We're going to go ahead and multiply our expression by 2. Okay, factor by grouping. Split the middle term, make your groups, take out the GCF from each group, and then factor out your new GCF or the common binomial. Okay, so we have 3w cubed plus 4z squared. And we are going to show the world what we're left with when we factor it from the expression. First term divided by the common factor, the binomials cancel out, and that will leave us with 2w cubed. second product divided by common factor. The binomials cancel out, and that will leave us with negative 9z squared. Fantastic. And let's not forget to bring down our common factor of 2. So if we were going to check it by hand, how will we do it? We will FOIL it out, distribute the 2, combine like terms, and then confirm that we end up with the original trinomial. Okay guys, so that was the 7th and final problem. So I think we're good for the day. Thanks.